Hello friends, in this video tutorial I'm going to bring about the idea of mathematical induction. What is induction? Inductive reasoning involves working with each case and developing a conjecture by observing incidences till we have observed each and every case. I am not presenting its definition as it's irrelevant to what we are going to learn, that is mathematical induction. So let me present you what is mathematical induction. So the mathematical induction involves proving a statement. So let us first of all call that statement Pn, and where n is a natural number as can be seen here. So in mathematical induction, what we do is we take a statement to be proven to be correct, and we prove it for n equal to 1. Say that is for P1 we prove that it is true. Then we take the assumption that the statement Pn is true for arbitrary n arbitrary k epsilon n, and use this to prove that the pk plus 1 is true, and hence we get that Pn is true for all natural numbers, that is Pn is true. I hope these steps are clear from the definition, or um, let's look into an example to understand the concept better. You must have seen this rule from in your elementary classes of the polynomials, and it's quite obvious, I suppose, that a if a and b are two real numbers, then a into b raised to the power n is equal to a raised to the power n into b raised to the power n, where n is some natural numbers. So let us try to prove this by by the mathematical induction process. So the process involves first assuming that the statement, that is the given statement, that is equal to Pn. So Pn is equal to ab raised to the power n equals to a into a to the power n into b to the power n. So the second step involves proving the statement to be true for the variable n equals to 1. So taking n equal to 1 in the equation, the LHS is equal to a b to the power 1, which is equal to ab, which is again equal to a raised to the power 1 into b raised to the power 1, which is same as the RHS. The next step involves, as you can see here, P1 is true. So the next step involves which is called the inductive hypothesis. Assuming that Pk is true, that is a b to the power k is equal to a to the power k into b to the power k for some natural number k, and trying to prove that p of k plus 1 is true. So to prove that, let's take the RHS, which is let's start with LHS first, that a into b to the power k plus 1, which will be equal to a into b to the power k plus into a into b. And now here in this step I've substituted using this result, that a into b raised to the power k equals to a to the power k into b to the power k, to get this. And after this I've just I just did a manipulation of adjusting the terms and clubbing this a with ak, and clubbing this v with b to the power k, to get a to the power k into a as one term into b to the power k into b as the second term. So as you can simply work out from this, that this term is equal to a to the power k plus 1, and the second term is equal to b to the power k plus 1. So which is equal to RHS if you just try to put n equals to k plus 1 here. And since LHS is equal to RHS, the pk plus 1 is true, and we have used the assumption here that pk was true. So the third step, that is the inductive hypothesis, yields that pk plus 1 is true if pk is true. Therefore by the process of mathematical induction, we can say that P of n is true for all n epsilon n. Uh, I have no more to teach you in this concept further, but you will find some of the examples in your textbook to be challenging. They are basically not because of your understanding of the concept of mathematical induction, but as you haven't worked out any of the uh, inequalities yet, so I would like you to work out the problems, and if you get stuck at the problem, just try to refer to some general reference book to get an idea of the inequality which is being used there. Thank you.